and then we have to take the ceiling of this, right? It is equals to 0 point negative 0 point, and then we have to take the ceiling, so we round it off to the nearest integer, so which is nearly equal to 0. Part number C, we have 3 here. Sorry, part number E, this is C, this is A. So part number 3 is 3. We take the ceiling of 3, it's still equal to 3 because there is no decimal. Part number G, we have this 1/2, 1 divided by 2, which is equals to 0.5. Then we have 3 divided by 2, which is equals to 0.5 plus 1/2 is equals to 0.5, and then we have 3 divided by 2, which is equals to 1.5. Now we have to take the ceiling of this, which is equals to 2, right? So we take 0.5 plus 2, and then we take the floor of this. So 0.5 plus 2.5 equals to 2.5, and then we take the floor of this. So therefore, this become here 2.
So wait, we take the floor after the 2.5 to get 2.
We take the floor after 2.5. Yeah, so we first solve this. 3 divided by 2 is 1.5, and then we take the ceiling of this, which is 2.
Right.
And then we have 2 plus 0.5, which is 2.5, and then we take the floor of 0.5, which is 2.
Okay. Thank you.
Any other questions? Okay, let's move to the next question. Okay, we have question number 17 here. So here in the question number 17, we have consider these functions from the set of teachers. Teachers in a school, under what conditions is that function one-to-one if it's assigned to a teacher, his or her office. Okay, so for the part number A, so we have to assign a one to, we have to say under what condition is the function one-to-one if it's assigned to a teacher, his or her office. So we basically, for this part A, when we are assigning it to an office, it depends on whether teacher shares offices or not. So if they share offices, then because they share offices, so therefore it won't be a function one-to-one. But if they are not sharing offices, then it will be a one-to-one. Part number B, assigned bus and a group of buses taking students on a field trip. So for the part B, so under what condition? So it's a one-to-one. If we assume, so one-to-one, assume only one teacher per bus. So if we only have one teacher per bus, therefore then it will be a one-to-one function. Part number C, salary. So so it's not going to be 1 to 1, because if salary is set by a collective negotiation agreement. So basically here, so if we have a teacher and then we have to define into what condition it will be a 1-to-1 for his salary. So if the salary is set by some collective negotiation agreement, then it won't be a 1-to-1. Okay, because salaries are mostly collective negotiation agreement, so therefore it's not 1-to-1. Part number D here. Part number is social security number, because every person has a unique cell number, so therefore it's a 1-to-1. Okay, so it's always, there is no condition, it's always a 1-to-1. Okay, moving on to next one. So we have this question number 25. So we assume that function is R to R and let f of x is greater than 0. So we know the domain that x is greater than 0 for all x belongs to the real number. Show that fx is strictly decreasing if and only if the function g of x equals to 1 over f of x is strictly increasing. Okay, so in this one, we suppose that f is strictly decreasing, because we have to show this, right? So we suppose that this is true. We suppose that f is strictly decreasing. So we know that this means that f of x, is greater than f of y. So when f is strictly decreasing, then it will mean that f of x is greater than f of y whenever x is greater than y. So when x is greater than y, the function of x is also going to be greater than f of y. And to show that g is strictly increasing, suppose that x is less than y. Okay, then g of x equals 1 over f of x. Okay, which is less than 1 over f of y, because we assume that g is strictly increasing, because it's an inverse relationship, right? That's why. So this here, this is our function g of y. Okay, so in other words, suppose that g is strictly increasing. This means that g of x is less than g of y whenever x is less than y. To show that f is strictly decreasing, suppose that x is less than y, then f of x equals 1 over g of x greater than 1 over g of y equals to f of y, hence proved. Okay, basically what we did here is we have to show that f of x is strictly decreasing under this condition when g of x equals to 1 over f of x. So what we did is we assumed that f is strictly, that's what we assumed. What we assumed that suppose that f is strictly decreasing, so it means that f of x here is greater than f of y. So if function is decreasing, right, whenever x is greater than y, its function is also greater than f of y. Okay, and then we have to show that g is strictly increasing. So when x is less than y, then g of x equals to 1 over f of x, which is less than 1 over f of y, and this is basically g of y. So in other words, what we said is suppose that g is strictly increasing. So this means that g of x is less than g of y whenever x is less than y, right? Because here we assume that f of x is greater than y whenever x is greater than y. So here f is strictly decreasing, but here we are saying g is strictly increasing. Okay, this means that g of x whenever x is less than y and g of x is less than y. So to show that, so we first prove this here, and then we first prove, and then we prove this. Okay, so to show that f is strictly decreasing, suppose that x is less than y, then f of x equals to, now notice this relationship here, right? So it's basically the inverse, right? So therefore it proves that g of x equals to 1 over f of x whenever it's strictly increasing. Okay, next question. So this is question number 29. So we have to show that the function f of x equals to absolute value of x. From this notation over here, it means absolute value of x from the set of real numbers to the set of non-negative real numbers is not invertible. But if the domain is restricted to the set of non-negative real numbers, the resulting is invertible. So the function here is basically not a 1, 2, 1 function. Okay, on the restricted domain, the function domain, the function is the identity function on non-negative real numbers. F of x equals x. So it's on inverse. Okay, so here this function is basically a a known one-to-one function, and then we have to show that the resulting function is invertible. So because we know that this function is not a one-to-one function, and then the domain here, if we just restrict that domain to very few numbers, this function is basically an identity function on non-negative real numbers. So basically f of x equals to x. So now if we take the domain as non-negative real numbers, so this function here, it becomes like this. So which is basically the its own inverse. Any questions? Right, if no question, let's move on further to exercise 2.4, which is on page 177, and it's basically based on the sequences and the series. Okay, so we have these terms of the sequence a to the power of n. So a n equals to 2 multiplied by minus here to the power n plus 5 to the power n. We have a 0, and then we have to find the value for this. So for the part a, in part A, so we have A when A is 0. So we basically have 2 dot 2 dot, or we can say 2 multiply as well. But because just to be consistent with the question, so say 2 dot minus 3 to the power of 0 plus 5 to the power of 0. Okay, this is basically equals to 2 dot 2 dot. So minus 3 to the power of 0 is 1, right? So 1 plus 5 to the power of 0 is also 1. So it's 2 plus 1, which is equals to 3. Okay, let's take B part. So we have a to the power of 1. So we will have the same thing here. But instead here we will put 1. Here we will put 1. So this here equals to 2. And negative 3 to the power of 1 is basically negative 3. Plus 5 to the power of 1 is 5. Okay, so minus 3 multiplied by 2 is minus 6. Minus 6 plus 5 equals to negative 1. Part C, same thing. Replace this with 4. So here we have negative 3 to the power of 4. Because here this is just similar to this, so and then I don't want to waste time on the calculation, so it's the direct answer, because I think that you guys have got the idea. So it's 787, just following the same steps. Okay, D, for the same thing here, we'll just replace it with 5. And after we plug in the values, we will get 2, 6, 3, 9. Any questions here? Okay, if no question, let's move on to our next question. So we have this question number 5 here. So we have to basically list the first 10 terms of each of the sequence here. So for the A part, for the A part, it says the sequence that begins with 2 and in which each a consecutive term is 3 more than the preceding term. So, and then there is an increment of 4 or 3. So we'll say 2, 5, 8, 11, 14, 17, 20, 23, 26, 29. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So we have listed out the first 10 terms of the sequence. That's your part number C. Sequence that lists the odd positive integers in increasing order, listing each odd integer twice. So whenever it's an odd integer, we have to basically include that twice. So it will be 1, right? The list of the odd positive integers. So 1, 1, and then 3, 3, and then 5, 5, and then 7, 7, and then 9, 9. E, the sequence that begins with 3, where each succeeding term is twice the preceding term. Okay, so here we know that it begins with 3, and then there is an twice. The next term is basically twice of the preceding term. So 3, 6, 12, 24, 48, 96, 19, 2, 3, 8, 4, 7, 6, 8, 1, 5, 3, 6. These are the first few terms, but of course the sequence keep going on. Okay, because we are only supposed to list the first 10 terms, so there we are. Okay, so these ones are part A, C, E. Any questions here? Okay, so if no question, let's move on to the next part. Okay, so we have to find the first Okay, we have to find the first 5 terms of the sequence defined by each of these recurrence relations and initial conditions. Okay, so here in the part A, okay, so we have A n equals to 6an minus 1 and a0 equals to 2. So because we have this recurrence relation here, and then we are supposed to know what are the first 5 terms based on this expression over here. So we have to plug in the values there to the first 5 terms. So when a equals 2, a0 equals 2, so we will say here, so 6 a here, n minus 1 here, n minus 1. So if I start with n equals to 1, right? So a to the power of n, power of n equals to 6an minus 1, and then we have a equals to 0. Okay. So for our first term here, we know that a0 equals to 2, right? So for when n equals to, when let's say n equals to n equals to 0, when n equals to 0, so a of 0, we know that a is 0, so this will make this 0, so a0 equals to 2. When n equals to 1, we will basically plug in the value. So 6a here, when n, and 1 minus 1 is 0, so 6a0 is 2, so 6 into 2 here, this one is basically 12, and then when n equals to 2 here, so we a0 equals to 2, and then we also know that a to the power of 1 equals to, so this becomes a1 here, so a1 equals to when n minus 12. Okay, so this is a0 equals to 2, a1 equals to 12. Okay, likewise we will do the same thing. So 6 to the power of a here, and n is 2, so 2 becomes 2 minus 1, and we know that a2 minus 1 is 2 minus 1 is 1, so we replace this a1 with this 12, so 6 multiplied by 12 here, so this becomes equals to 72. Okay, and then we keep doing this for n equals to 1, 2, 3, 4, 5. Okay, so the sequence will be 2, 12, 72, 432, 2, 5, 9, 2. Okay, basically what we have to do is we will have to start with a equals when a0 equals 2, and then we will just find the previous value to plug into the following value, find the answers for the next terms. Okay, let's do part C here. So part C, likewise, I won't be wasting time doing all the details. So here, so I'm just gonna list the answers right away. So it's basically just an minus 1 and 3an minus 2, and then this is a0 equals to 1, a1 equals to 2. Okay. So the answer here for the part C is 1, 2, 5, 11, and 26. Okay, part E. Let's do the D as well. So for the D, it's 1, 1, 6, 2, 7, 2, 2, 4. For part E, it's 1, 2, 0, 1, and 3. Okay, so we will have to find the previous value in order to plug it into the next values. Any questions here?
It's all good.
Yes.
Yep.
All good. Okay, let's move on to the next question. So in this sequence, a solution of the recurrence relation an equals to 8an minus 1. So we have to basically find the values for these two different ones. So when an equals to 0, so what are going to be the values for these? So this is okay. So in this question, to these different values, does the solution exist for this sequence, which is defined by this relationship here? So 8a n minus 1 minus 16a n minus 2. Okay. So when a n equals to 0, so we just put in this value a n equals to 0 over here, and then we will see that there is actually a solution existing for this expression. So therefore, we will see that there is a solution for these ones. Remember, see here. So when an equals to 2n, right? So we will plug in this value for an in this equation here, right? And then we will find out that this equation over here, when an equals to 2 to the power of n, it doesn't really have a solution. So therefore, we will say that it doesn't have a solution. Right?
But how do you know it?
So just like we plug in the values and did the solution for this, right? So we keep plugging in the values to see.
Okay.
Yeah, so we keep plugging in the values. So for example, this one here, right? So when a1, for the a1, we basically need the value for a0, right? right? In order to find an answer for
Mhm.
next term, right? Because our next term is dependent on our previous term here. So therefore, we have to do this likewise calculation here to find out whether the solution exists when a n equals to these different values over here or not for this particular sequence.
All right, thanks.
Okay. So likewise for E, I'm just so basically it will be just the same work here, right? So I'm just letting you know the answers, and then you guys can, if you guys still have any questions, so we can probably go over the solution in the next tutorial. Okay, but do let me know at least 1 or 2 days before. Okay, so for the part G, likewise will be a no as well. Okay, let's move on to the next question here. So we have to find the solution. We have to find the solution to each of these recurrence relations and initial conditions, and then use an iterative approach such as that used in example 10. We haven't seen the example 10, but it's very similar. So it's very similar to this over here. So for this, we have to use an iterative approaches like when you sort of go in a loop, and in order to find the next value, you have to basically figure out the previous values. Yeah. So here we have a to the power a0 equals to 2, and then we have to find out so here we have this initial. So here we have this initial condition as a0 equals to 2, and then here we have this recurrence relation here, an equals to 3, an minus 1. We have to use an iterative approach. So just like we used in these examples over here, right, to find the solution for these relationship. Okay. So likewise, we did here. Here, a n equals to 3n minus 1. So plugging in the values and from the previous ones, so we will get the value for the iterative solution as an equals to 2 just 3 to the power of n. Okay, so there is an iterative approach. This is the solution for this reconciliation using the iterative approach. Okay, so I think you guys have already covered in the slide, so make sure to refer to the slide in case of any question, or you can also reach back to me if you have any question for a particular question. Okay, likewise for the C part here, so we will have 8 to the power of n equals to 1 plus n over n plus 1 divide by 2, divide by 2. Okay, part E here, we have 8 to the power. We have A, part E, A to the power of N equals to 1. And then we have part G here, which is A to the power of N equals to 5n factorial. So this is the sign for the factorial. Okay. Let's move on to the last question of this exercise. So this is relating the summation. So this is the sign of the summation. We'll basically, in this exercise, mostly what we do is we keep plugging in the values to find the next term in the sequence. So here, likewise, summation is like a sequence, but all the values in the sequence are summed up. So here, when we start with k equals to 1, so we just start replacing it with these values, and then we will sum up all the sequence. So let's take a look at part number A. So part number A is we have to do the summation here. So here k, the value of k, it starts with 1 and it goes up till 5. So the first term will be, so 1 plus 1 equals to 2, plus the next is 2 plus 1, which is 3, plus next is 3 plus 1, which is 4, and then plus, and then the next is, so this is when k equals to 1, k equals to 2, k equals to 3. When k equals to 4, so this is 4 plus 1, is just 5. And then k equals to 5, this is going to be 6. So if we sum this up, so it's going to be 20. Part number B. So we start from 0 and then we go up to 4. We have minus to the power of j. So we have this minus 2 to the power of j. Here, when j equals to 0, I'm just going to copy and then I'm going to paste it a couple of times. So we have some 0, 1, 2, 3, 4. So it's going to be 5 times. So when j equals to here 0, when j equals to 1, j equals to 2, j equals to 3, j equals to 4, right? And then we will find out the values for this. And this summation here evaluates to 11. Part number C here. So in part number C, we have this 3, and then we have this variable I equals to 1, and then we have it's going up to 10, okay? So because we don't have any variable inside this equation, right, which we are summing over. So we will, so when I equals to 1, we will say 3, and then this is when I equals to 1. When I equals to 2, it still remains 3. And then when I equals to 3, it remains 3. Remains 3 for when I equals to 4, and then we do this up till I equals to 10. So we have basically 10 3s, so this is 10 multiplied by 3, therefore it is 30. We have this 10 because it's going looping from 1 up till 10, so we have this 3 10 times, so therefore we get the answer 30. Okay, next question, deeper. So here it's a little complicated over here. So what we do is 2 to the power of j plus 1 minus 2 to the power of j. And then there is a plus sign. Okay, so we have to do this 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So here, when j starts from 0, so this is 0. J in the first term is 0. In the next term, it becomes 1. And then 0 plus 1 is, let's simplify it. So it becomes 1. 1 plus 1 here equals to 2. Now, here 0, 1. So this is 2. This is 2 as well. This is 3. This is 3 as well. This is 4. J is 4. 5. J is 5. 6. J is 6. 7. J is 7. And then we need another one for 8 because it's going up till 8. So this is here 8. So 2 plus 1 here equals 2. 3. 3 plus 1 equals 2. 4. 4 plus 1 equals 2. 5. 5 plus 1 equals 2. 6. 6 plus 1 equals 2. 7. 7 plus 1 is 8 and 8, and this one here is 9. Okay, and we will solve this, and then the answer here for this part here is 511. Any questions?
What was the answer for question 17G again?
Question 17G.
Yeah.
Yeah.
Oh, H. Yeah, that one. Yeah.
G or H?
Yep. G, my bad. Yep. Okay, got it. Yeah.
So this is the sign of victory. Okay. Okay. Any questions from this question here? Okay, if no question, let's move on to the next exercise. So this next exercise is exercise 2.6, which is on the page 193 of your textbook. Okay, so this exercise basically involves the use of matrices and matrices. Okay? So here we have this matrix A, which is over here, and then we are asked what the size of A is. So the size of A is basically, if we notice here, so it has 3 rows and 4 columns, and the size of a row matrix is explained by row into columns. So here, if we see here, so it has 3 rows and it has 4 columns. So therefore, this is the size of A. Okay, so here we are asked what is the third column of A. So this is 1, 2, 3. So it will be 1, 1, 1, 4, 3. So basically, you guys are supposed to write it like this as a single matrix, not like this. Okay, so you'll be writing it. You will put this brackets around, and you will only have 1, 4, and 3, like I can show you here. So you can have this one here, these brackets. So it will be 1, 4, and then 3. Okay. Okay, so this is part B. Part C here. So what is the second row of A? So here we will be writing it out. So 2, 0, 4, and 6, because that is the second row of A. Okay. So 2, 0, 4, 6 is the second row of A. And part number D. So what is the element of A in the 3-tooth position? So this here is the third row here. So if we go here, so third row, so 1, 2, 3, and the second column, so 1, 2. So it's this element here. Okay, so the element here at 3-tooth position is 1. Okay, then the E part here, so E part basically asks for AT. AT here, it means that A transpose here. So they're asking for what the transpose is for AT. So here, so the transpose here, so what we do is we will write this columns as rows in the transpose and rows as columns. So we have this column, we will convert this to a row. So 1, 2, 1, and then we have 1, 0, 1. So 1, 0, 1, then we have 1, 4, 3, 1, 4, 3, and then we have 3, 6, 7. So 3, 6, the 7, closing the brackets. This is A transpose. Okay. Any questions? Okay, if no questions, let's move on to the next question. So this is question number 5, and here what we have to do is we have to find the matrix A such that the resulting matrix is 3, 1, 0, 2. So when we multiply 2, 1, 3, 4 with the matrix A, so we get 3, 1, 0, 2, and then we have given the hint that finding A requires that you solve systems of linear equations here. So we have this. So 2A equals to 3 here. So if we have this here, so we have this 2, 1, 3, 3, and then this 4 here. We are supposed to multiply this with A such that the answer is 3, 1, 0, 2. Okay. So let's assume that A over here is X, Y, Z, maybe W. So when we multiply this, so this 2 over here gets multiplied by this 2. So 2x, so we'll form the linear equations. 2x plus 3y. This term here, this over here, gets multiplied by this over here to get this over here equals to 3. Then we multiply this with this over here to get this. Okay, so 2z plus 3w equals to 1. Okay, then we do the same thing with these ones. So 1 over 4 multiplied by this 1x plus 4y equals to 0. And then 1x plus, sorry, 1z plus 4w equals to 2. Okay, and then we solve these equations using the linear algebra, and then we will find out the answer for these is 9 over 5 is the value of x minus 1 over 5 is the value of y minus 6 over 5 is the value of z, and then 4 over 5 is the value of w. Okay, so this over here is the answer. Okay, and if we multiply this with 2, 1, 3, 4, so if you multiply these two matrices, we will get this as a result. Okay. Any questions? Okay, let's move on to question number 11. So on the question number 11, we are asked to make a deduction about what do we know about the size of the matrices A and B if both of the products A, B, and B are defined. That is, their product is basically equals to something. Okay, so the number of rows of A equals the number of columns of B. If they have the product as defined, so we know that the number of rows of A equals, so this matrix over here, this is basically the result of the numbers of rows of A, and the size of this matrix is basically defined by that. So the number of rows of A equals to the number of columns of B, and the number of columns of A equals and the numbers of columns of A equals the number of rows of B. Okay, so this is what we know about the size of matrix A and B if they both have the product defined. Okay, next question. So in this question here, we suppose that A is a n by n matrix where n is a positive integer, and then we are supposed to know that show that A plus A to the power of A transpose is symmetric. So if we have let's say a matrix A to this n into n size, right? So let's say we have a matrix where n equals to 2, right? So it will be a 2 by 2 matrix. So let's say 1, 2, 3, 4. And then the transpose, so let's say this is A. And the transpose of this will be 1, 2, 3, 4. This is the transpose for A. Okay, so we are supposed to show that A plus A transpose, so this one over here is symmetric. That is, they have the same values at the same places. Okay, so whatever the result of this is, A plus AT, so A, B, C, D. Let's say this is the result of this one here, right? So it should be symmetric. So the other one should be A, B, C, D over here as well. Okay, so in order to solve this, the ijth, so I basically represent the row and the j represent the column number for a particular element. So in order to refer to an element, we will basically refer to it using this position ith and jth position. Okay, so the ijth entry of A plus A to the power of A transpose is A ij plus A ji. Okay, right? So if this here is at position 1 1, and then if I take the transpose of this, it still remains at the position 1 1. Okay, which equals A ji plus A ij. The ji's entry of A plus A transpose. So by definition of symmetric, A plus A transpose is symmetric. Okay, so basically what we said here is, so we know that this, so we suppose that there is an entry ij, right? So this, let's say this entry here is represented as I and j in the matrix A, right? In the matrix A. And if we take the transpose of it and then we add it with A, right, it still remains on the same position, ij, right? Because these positions here, they remain the same for the elements in the matrix A and for the elements in the matrix A plus A transpose. So therefore, by the definition of symmetry, we know that A plus A transpose is symmetric to A. Questions? Okay, no question. Let's move on to the next and the last part. Okay. So we have these two matrices over here, A and B. And then we're supposed to find A. The sign over here is the sign for A or B. Okay, so we can also call it the union, A union B. We have this matrix here. So A 1 1 0. Then we have this 0 1 0. Then we have 1 0 1. Okay, and then we are doing the A part here, so it's A union or 0 1 1 1 0 0 and 1, 1, 1. Okay. Here. So because this is an OR, so we take this value and then we take the corresponding value in the next one. So this is 1 and or 0. So 1, 0 is 1, right here. Okay, so I'm just gonna remove this here. So this is 1, 0, 1, and then take this 1 and 1, 1, 1 is 1, 0, 1 is 1, 0, 1 over here is 1, 1, and then this 0 here is 1, this 0 here, and this 0 here is 0, 1, and then this 1 here is 1, okay, and then this 0 here, and then this 1 here is 1, this 1 here, and this 1 here is 1, okay. So this is the result for part A. This is the result of part A. Okay, part B, we have A, we have A intersection B, or A and B. Okay. So we have this 1 over here, and then this 0 here. 1, 0 is 0. 1, 1 is 1. 0, 1 is 0. 0, 1 is 0. 1, 0 is 0. 0, 0 is 0 again. 1, 1 is 1. 0, 1 is 0. And then 1, 1 is 1. Okay. Okay, so this is gonna be for part B. This is gonna be the result. Okay, so for part C here, so this is basically called here a dot product. So basically we have two kinds of product in matrices. We have it's called a cross product, and we have a Cartesian product or a cross product, and then there is another this dot product. Okay, so we will see here. Okay, so this is a dot product. Okay, so here we have this 1, 1, 1, 1, 1, 0. Okay, and then 1, 1, 1 has the dot product of these two matrices. Okay, so this number over here, this 1 over here, I got it by multiplying this whole thing with this thing and adding it. So I did 1 multiply by this 0 here, and then I did plus 0 multiplied by 1 plus this 1 multiplied by 1. So here, this is 0, this is 0, this is 1. So 0 plus 0 plus 1 equals to 1, and therefore we get this 1 over here. Okay, likewise you do it for all of them, and then we get the other entries in the matrix. Questions? Any questions, guys?
Just one question. So when you do the dot product, you just do the row, multiply the column, and then you add the numbers together.
Yeah.
So you just do the row times the column, and you just add them together.
Yes, basically in order to, so this is a dot product, right? So this is a dot product here. So in order to get the answer for the dot product here, what you do is you take this whole row and then you multiply it with this column of the other matrix. So you do the first value with the first one, then you add it with the second value, and then you add it with the third value here. You do it for the other ones as well, so you get the values for the resulting matrix.
Right. Okay.
Okay, and then you keep on doing it until you get all the values. Okay.
Yep. Thank you.
But in the first row, third column, aren't you supposed to have two?
Sorry, which one?
First row, third column.
The
You
first
did 1 times 1 is 1. No, like when you do the dot product in the solution. Like when you time the row of the first matrix times the third column of the matrix, you have 1 times 1 is 1, then 0 times 0 is 0, then 1 times 1 is 1. It's 1 plus 1 is 2, right?
sorry, which value you are talking about? This value here? This value?
No, the third one.
This
third.
one? This one?
Yes.
Okay, you're doing this one. Okay, and then what are you saying about it?
Isn't it supposed to be 2?
How you are doing this with your which columns and rows are you taking?
the one that you're in, that row, and the last column of the second matrix.
Okay, so you're doing this with this here.
Uh-huh.
To get this.
Sorry. Yes. So it's 1 times 1 plus 0 times 1 plus 1 times 1, right? So it's 2, it's 1 plus 0 plus 1.
Okay. So here we have, so we do this 1 multiplied by 1 here, right? 1 multiplied by 1 is 1. Then the 0 multiplied by 1. And then we have this 1, which is multiplied by 1. Okay. Yeah, I see what you mean. Yeah, you're right. So it should be 2 actually. It should not be 1. Yeah, thanks for pointing that out. Yeah, so it should be 2, yeah. So I think there are different kind of matrices as well. I'm sorry?
Oh, okay. Like in this case, we don't only add them, we do the OR.
You go ahead.
Yes, I was saying, like, in this kind of matrices, do we add them or we OR them?
We add them. We add. So here, this dot product, right? So we add them. There's a plus sign here. Okay, any other questions? Okay, if there are no more questions, guys, I'll see you guys in the next tutorial. I think there is no tutorial next week. So the week after that, I will be having a tutorial. So, good luck for your exam on Tuesday. All right, so
But the professor said that we are supposed to have.
I'm sorry?
Hello?
Yes.
Professor said that we are supposed to have like 1 extra hour, I think, on Monday.
Okay, so I think you probably have to check the course announcement. I think there might be a course announcement for that as well. So make sure to check that out. And yeah, if you guys have any questions, just make sure to email me at least 1 or 2 days so that I have enough time to keep that in my mind. Okay, so that's pretty much it for today's tutorial, and I will be uploading the notes and the tutorial video recording on the website, so make sure to check that out in case you need some help. Just let me know, and I'll see you guys in the next tutorial. All right, thank you guys, bye.
All right, thank you so much.
All
Bye,
right,
man.
bye.